And welcome back, boys and girls. I have decided to put my video back on here um, just for something different. So today we are looking at Lesson 20, Session 1. And this is on page 465 of the second book. So Lesson 20, Session 1, page 465. Make sure you've got a pencil. And this is an Explore Solutions of Equations. So complete the problems about modeling equations. Number 1. The equal sign in an equation shows that the expression on the left side has the same value as the expression on the right side. A bar model can represent the relationship between the two sides of an equation. Circle each equation that the bar model represents. So I want you to stop and see if you can't figure out what does that bar model represent. All right, you should have circled. I think this one's pretty obvious. The 4 plus 3 is 7, and 7 is equal to 3 plus 4, and 7 minus 4 is equal to 3, and 4 is equal to 7 minus 3. So whatever is on this side of the equal sign is equal to this side. It's kind of like a balance. That's how I think about that equal sign. It keeps it balanced on either side. So hopefully you got that. Write two different equations that represent each of the bar models represents. So stop the video. I need two different equations. So remember, that means I need an equal sign for each one of these, and then come back and see if we got the same thing. Okay, so on A, you could have done 3 groups of 4 is equal to 12, or you could have done 12 divided by 3 equal 4. I could have done 4 plus 4 plus 4 is equal to 12, which would have been the same as 3 times 4. For number 2, hopefully you saw that this would be 2 plus x equal 10, because this plus this amount, even though we don't know what it is equal to 10. So that means if I had 10 and I took away the x, I would have 2. Now you could have written these in other ways, but these are possible examples. And C, I have 4 y's, 4 groups of y. So I could do 4y equal 8. I could have done y plus y plus y plus y. I could have done 8 divided by 4 is equal to y. So like I said, you could have had other solutions as long as they were similar or had the same meaning. And let's go ahead and look at the next page. Complete the model to represent each equation. So we need 15 is the same as 3 plus x. So how would I show that? And the next one, 15 is equal to 3 times x. So that your picture should look a little different. So why don't you stop the video and then come back to see how you should have done it. Okay, on this first one, because I'm adding the 2, that means I've got 3. Now you could have made your sizes different. And x is equal to 15, because if I put the 2 together, I get 15. On the next one, I have 3 groups of x. So I have x, x, x. And that is equal to 15. Okay, so number 4. An equation is true when its sides have the same value. A value of a variable that makes an equation true is a solution of the equation. Use your models from problem 3 to find a solution for each equation. Explain your reasoning. And I know these look really simple, so I want you to see if you can't think about it like a balance. We've got 15 on one side, and 3 plus something is equal to 15. Hopefully you know that the answer should be 12, because the model showed 15, and we took 3 away, I would have 12 left. So my model shows that x is equal to 15 minus 3, or 12. And so when x is 12, both sides of the equations are equal. For part B, you should have had, the answer should have been 5. Because when I have 3 groups of 5, my answer is 15. So my model shows that I have 3 groups of 5, which is equal to the same value as 15. Okay, pretty simple here. So let's go to reflect. Explain what the equation 3x equals 6 means without using the word equal. I would like you to try to do this. Explain why 2 is a solution of the equation. What does 3x equals 6 mean? And don't use that word equal. Write it down. So you could have said 3x has the same value as 6. 3x has the same value. They're equal. They're balanced. So 3 times x is the same amount as 6. And we know that the number 2 is a solution, because when x is equal to 2, then it balances out our equation. And I did not write that down, but you can write your notes down. And then I want to go ahead and look at this. This is actually part of your homework, but I always think it's easier if we kind of do this one together. So number 1, think about what you know about expressions and fill in the box. Use words, numbers, and pictures. Show as many ideas as you can. So what are equivalent expressions? They are 2 or more expressions that have the same value. So you could write expressions with the same value. With the same value. An illustration could be like we did, if we would a picture where we went, let's say this is 6, this is 6, that makes that 12. And we had M and M, that's 2 M's. So that would be 12 plus 2M. That is a 6, by the way. So an illustration, or like a bar model. An example you could do, pretty easy, 2 plus 3 and 5. Those are equivalent. You could do 1/2 of x. That's the same as x divided by 2. A non-example would be 2 plus 3 and 6. Those are not balanced. That does not equal each other. So we're going to stop there. I think this is a pretty easy concept. You do need to do number 2 on this page by yourself, 467, and then complete the next page for homework, numbers 3 through 5 on page 468. And we will continue tomorrow.